observe these two experimental setups. In this, I have taken this a source of light which is monochromatic, point source of light. This is just a cardboard with two holes in it, two pinholes. Cardboard with two holes should be very close. This is a monochromatic source of light. The best monochromatic source of light available nowadays is laser light. We can use a laser torch, and these are to be kept very small. And this is the screen. Or this arrangement is more or less same. The only difference is here I am taking slits and it is point source. It will give same type of results. S again a monochromatic source of light, cardboard, a slit into it, and we have divided the light into two parts, two slits, and these are the fringes. Fringes actually are, we will get fringes here also. Fringes means these are dark and bright bands of light. Whenever we have a monochromatic source of light, then it is divided into two parts, two slits, narrow openings, and then on the screen we see this is the central bright band followed by a dark band, then bright, here it is dark and then bright. So alternate dark, bright, we get such type of bands of light. Same way here, I have used point sources and then again a cardboard with two holes. On the screen we get again dark and bright bands of light. These bands of lights we call them fringes. Now I am showing you an activity. First one, I have taken two sources to produce two waves on water surface. I have tried to keep the frequency same, and same way another one I am just explaining that on paper, that if we have lots of crust and troughs going from this point and then same point, what is the resultant that we get? How do we get these maximas and minimas? Observe these two things and then we will do the mathematical formulations here. So we saw in Young's double slit experiment that we have a monochromatic source of light. The light is divided into two parts by taking a cardboard, making two holes in it, and then a screen is placed. And we have discussed why we are not taking two independent sources, because they are not coherent. What we need to get maximas and minimas is the wavelength of light, the frequency of the light should be same, and the phase difference shouldn't change with time. So this is the reason why we are taking single monochromatic source. So same wavelength of light, and whatever changes take place here, the same changes go to S1 and S2, so the phase difference does not change with time. If it is 0, then it remains 0 only. Or if it is something else, if I have kept it at center, then both the waves, waves moving here, and this path exactly same. So path difference here is 0. So 0 path difference is there when the waves are coming out of S1 and S2. So whenever we see the intensity on any line here on the screen, it will depend on the path difference here only. Whatever phase difference will come, that will come because of different lengths of paths. No other cause for phase difference, because light is coming from a single source. Okay, now we have seen how maximas and minimas are formed. Now let us do it mathematically. Let us take vibrations due to first wave and due to second wave. I have not taken waves equation, omega t minus kx, and this same way we should include kx also, but I am taking a fixed point, so x is fixed. That's why I have ignored that. I am taking only omega t and omega t plus 5. So though two simple harmonic motions at point P, position fixed, and with time, this is the displacement due to first wave, this is the displacement due to second wave. Same amplitude, same frequency. The only difference is phase, and phase will be different because one wave is covering S1P, another one is covering S2P. And we have seen earlier, logically I told you what should be the value of S2P minus S1P to get maximal and to get minimas. Now we will do it mathematically. What is Y? Principle of superposition of says it is just the sum of the two. So it is A cos omega t plus A cos omega t plus phi. A can be taken out. We can apply the expression cos C plus cos D. This is the result. Cos C plus cos D, cos C plus D by 2, cos C minus D by 2, C plus D by 2, C minus D, cos minus theta is cos theta, so I use that. Now, this term, omega t plus phi by 2, time dependent. So it's again equation of a wave. It is telling us what will be the net simple harmonic motions at this point P. Now this is the amplitude. So amplitude is not two-way. This is a very important point, that one wave has the amplitude A, another one also has amplitude A, but the net is not two-way. It is depending on phase. It is depending on the phase difference. When the phase difference is 0, it should be 2A. When the phase difference is lambda by 2, pi, or part difference lambda by 2, then it will become 0. So let us see. This is the amplitude. So amplitude is 2A cos phi by 2, or intensity, the square of it. Okay, let's first do the amplitude part. 2A cos phi by 2. Now let us see when will it be maximum. 2A cos phi by 2. Amplitude. This is maximum for crust or trough, either plus 1 or minus 1. And minimum will be 0 because I have taken amplitudes of both the waves same. So for A to be maximum, cos phi by 2, this should be plus minus 1, which means phi by 2 should be 0, pi, 2 pi, 3 pi. Cos 0 is 1, cos pi is minus 1, cos 2 pi is 0, and then 3 pi again minus 1, and so on. So phi needs to be 0, 2 pi, 4 pi, 6 pi, or I can say it is even multiple of pi. This gives maximum. We have already done it. Or in terms of path difference, phase difference is equal to 2 pi by lambda into path difference. So del x will be n lambda. This is the condition to get maximum intensity. The phase difference or the path difference S2P minus S1P should be a multiple of n lambda. We discussed it logically, how lambda, 2 lambda, 3 lambda, 4 lambda gives us maxima. Now we have derived it mathematically. For minimum amplitude, it will be 0. So it means phi by 2 should be pi by 2 or 3 pi by 2 or 5 by 2 and so on. So phi is pi, 3 pi, 5 pi or 2n minus 1 pi. Odd multiple of pi. Odd multiple of pi will give us minima. In terms of path difference, again phase difference is 2 pi by lambda into path difference. So del x is 2n minus 1 lambda by 2, where n will start from 1. So these are the conditions to get maxima and minima. And we can see from here what will be the value of maximum amplitude, 2a. So what will be the maximum intensity? 4a square, or I can say 4I naught if I is the intensity, I naught is the intensity due to individual waves. Okay, and A minimum will be 0, so I minimum will be 0. This is when the amplitudes of the two waves are same. For different amplitudes, we can derive again A sine A cos omega t, and here I can write B cos omega t plus pi, then you can derive the entire expression again. I can give you the final result if you want. And intensity will be then I1 plus I2 plus 2 under root I1 I2 cos phi. This is when the amplitudes are not same. So I max will be under root I1 plus under root I2 whole square, and I minimum will be under root I1 minus under root I2 whole square. We can work out from maximum and minimum amplitude too. R maximum will be A plus B, and R minimum will be A minus B. We can derive this expression also, not very difficult, but even then, some books have given this expression, no NCERT doesn't cover it, but even then, for you, some extra knowledge, you can take it. Y is equal to A sine omega t, or I can take even cos, that doesn't matter. Y2 B sine omega t plus phi. Even cos won't make any difference. We know in simple harmonic motion whether it is sine or cosine functions, the final result will be same. Okay, what will be the net amplitude? Net displacement, sorry, y1 plus I2. So A sine omega t plus B. I'm using now here sine A cos B. So sine A cos B plus cos A sine B. Sine omega t A plus B cos phi plus cos omega t, and here we have b sin phi. Now just a mathematical trick, how can we write? We are adding two sine functions, the net result should also be sine function. How can it be written in sine? Sin a cos b plus cos a sin b, something like that. Sin a cos b plus cos a sin b. Let us assume it's something. Sin a cos b. Let it be a cos theta, sin a cos b plus cos a sin b. Let it be a sin theta. I have assumed a sin theta is this. So let a plus b cos phi be a cos theta and b sin b a sin theta. See, I can't assume anything anytime, but if we are taking some other function, some other value, some other term, its value should be known to us. I have included here a and theta. These are unknown, so I have to find out the value of a and theta. Same way around, right? So using these two, I can find out the value of a and theta. How? If I divide, I will get tan theta. Theta will be known. If I square and add them, I will get a. Okay. So for the time being, what will it be? A sin a cos b plus cos a sin b. It becomes sin a plus b. Sin a plus, b. This is the first wave, vibrations due to the first wave, these are the vibrations due to the second wave, and this is the resultant vibration. So it still has the same frequency, but amplitude again has changed, and amplitude is squaring and adding these two terms. A square cos square theta plus sin square theta, it is equal to squaring and adding a square plus b square cos square phi plus 2ab cos phi plus b square sin square phi. This becomes b square. So it is a square plus b square plus 2ab cos phi. This is a square. So amplitude is, this is what I told you there. Now amplitude is a square plus b square plus 2ab cos phi under root. So this is the amplitude of net amplitude due to the two waves. A can be maximum when cos phi is 1. A max become a square plus b square plus 2ab under root a plus b, and when cos phi is 1, phi should be 2n pi, 0, 2 pi, 4 pi, right? For a minimum, a minus b, when it is 2n minus 1 pi. If it is pi, 3 pi, 5 pi, it will become minus 1, so it will be a square plus b square minus 2ab. A will be minimum. A square plus b square plus 2ab, it will be maximum when cos phi is 1. So a maximum, a plus b, a minus this. And if we talk about intensity, or a square plus b square plus 2ab cos phi. Now see, if a is the amplitude of the first wave, b is the amplitude due to the second wave, so what will be I1, I2? A square, b square. So this is I1, this is I2 plus 2 under root I1, I2 cos phi. It is actually proportional to it. So if we take this proportionality k, here also k, that k gets cancelled and I will get this. So this is I general expression. I maximum, it will be, I'm coming to it. This is general expression for I max, it is 1. So it becomes under root I1 plus under root I2 whole square. And I minimum, it becomes this. Maximum intensity, minimum intensity. In the first case, I took the amplitudes of the two waves same. In that case, this becomes just 2 under root I square, so it is 4I. If we are getting maximum at one point, maxima, it means the intensity is 4 times the intensity of 1. So if I close 1, the intensity will be reduced to 1/4 at maxima. At minimas, the intensity is 0. So there is still the conservation of energy. At maximas, the intensity is not just the sum of the two, it is more than that. So there is just redistribution of intensity, redistribution of energy, but it is still conserved. So it's all about interference, maximas, minimas, coherent sources of light, and then expressions for the intensity general, and then for maxima, for minima, the conditions to get maxima and minima, and coherent sources of light. That's very important. So this all covers interference of light.